There is no darkness so dense, so menacing, or so difficult that it cannot be overcome by light. Have you ever thought about what it would be like to live without light? Very rarely do we experience total darkness. Light is used eternally, and we rarely notice how important it really is. To further enhance your knowledge about the fascinating theory, I will explain the following. First, simply what is light? Second, how is it created? And lastly, why is it important? In simpler terms, light is the smallest quantity of energy that can be transported. Light consists of photons, which is an elementary particle without an exact size that can't be split, only created or destroyed. Light also has something rather confusing, a wave-particle duality, meaning it acts kind of like a particle and a wave at the same time. Humans are only able to see a small fraction of the visible light of the electromagnetic spectrum, energy in the form of electromagnetic radiation. This electromagnetic radiation consists of a huge range of frequencies and wavelengths. The spectrum starts off with gamma radiation. Gamma rays have the smallest wavelengths because they have the photons with the most energy, but gamma rays usually tend to be smaller than a hydrogen atom. Next is the X-ray. X-ray have the longest wavelength than gamma rays, but shorter than ultraviolet. X-rays are used to image your teeth, for airport security, and to examine what's happening in the body. After X-rays, there are ultraviolet, also known as UV rays. UV rays are shorter than visible light, but longer than X-rays. UV rays come from the sun and can cause burns and tans. Visible light is in the middle of the spectrum, within the 400 nanometer to 700 nanometer range. For reference, that's about the size of a bacteria. Following visible light is infrared radiation. Infrared radiation has a longer wavelength and lower frequency than visible light. It is used in night goggles to detect heat. Next is microwave radiation. We are very familiar with microwave radiation, for it is to heat food. And finally, the last radiation on the spectrum is radio waves. Radio waves can measure up to 100 kilometers in diameter, while the largest wavelengths measured up from a span to 10,000 kilometers to a jaw-dropping 100,000 kilometers. But all these waves are the same. They all have a wave-particle duality, and they all travel at the speed of light, just at different frequencies. So you're probably thinking, then what makes visible light so special that we can see it? The answer is quite simple. Nothing makes visible light special. We just have eyes which have evolved that can address the exact part of the spectrum. So how is light created? Me saying that makes me look stupid because light is obviously created from the sun, but science needs to make things complicated. The earliest form of light comes from explosions on the sun's surface, making sunlight. The next form of light is lightning, which gave us our third form of light, fire. Later we started to harness the light energy from fossil fuel, emitting gas, using the gas lamps. Throughout further advancements in science, we created DC current, which used the light bulb. Due to DC current's inability to travel long distances, Nikola Tesla created AC current that ultimately allowed a distribution of a cheap source of energy lighting up the entire world. So basically, the way light is triggered is a product of a huge electromagnetic waves, which is created when electrons drop from a higher state of energy to a lower one. They lose their energy and result emitting radiation. Microscopically, visible light is created when an electron in a triggered state drops to a lower state and loses its energy. This also works in reverse. Incoming light can bring an electron to a higher state by absorbing it. Macroscopically, the charge of an electron creates a swaying magnetic field, which creates another swaying electric field perpendicular to it. These fields are moving freely through space, transferring energy from one place to another. So why is light important? Light is an important tool for guidance for both plants and humans. Humans need light to go about our daily activities. Currently, technological advancements allow people to exploit other beneficial uses of light, such as solar power. The light from the sun is used to power many different devices around the world. Who knows what we'll invent in the future? Ever since we harnessed light, we made so many advancements that gave us a better understanding of the phenomenon. Who knows? Maybe in the future we'll be able to heal severe wounds using light. Thank you, and yeah.